Okay, so today we're going to learn solving problems using two variables. As you remember from first semester, when we had word problems, I said just use how many variables?
Two.
In first semester, one variable. Now that we're in second semester, guess what we're going to do now? So these problems are the same kind of problems that you've seen before. Now, only difference is I'm going to show you how to use two variables because last time we learned how to solve equations systems of equations using which method? Substitution method. So now that we've learned substitution method, you can now use two variables. Is that okay? So what I want you to do first is go ahead and write the first question down. Here it is. Go ahead. Okay. So who can tell me? Now, when you use two variables though, guess how many equations you will need to solve? Yes? No? If you have two variables, you will need two different equations. Obviously, having the same one doesn't help you, right? So you need two different equations. So does anybody see two? First of all, what are my unknowns? There are two unknowns that we're going to use because... Sabrina? Yeah, let what? Yeah, let x be the first number or the smaller number. Yeah, I think, yeah. Let x be the smaller number. Brian, what's the other one?
The other one is 5 minus x.
Oh, yeah, that's what we did in the very first semester. Okay. So now we're going to use two variables. You're right. So, I mean, like I said before, you could just use one variable and solve these things. But I'm showing you how to now I'm showing you how to use two variables. You will see that when we get some like problems that are a little bit complicated, it's best to use more than one variable. So who could tell me? Brian? Yeah, go ahead.
Well, I was just asking Caleb what he got as the variables.
Okay, but yeah, Berge?
When you say like two variables, do you mean like two x's or like...
Oh, no, two different variables. Yeah, two different variables. Right. So like x, y, a, b. Yeah. Yeah, let y be the larger number. Is that okay? Question? Yeah, no, you could do that if you like, but since we're declaring two variables, you could do let x be something and let y be something. Yeah.
So you just do an equation?
Yeah, when you do then, that's when you're using this one variable. Things like that.
Okay.
Yeah. So who could tell me, so now now that we have two variables that are different, we need two different equations. Can somebody give me one of them? Because this one is always the one that people always skip for some reason, because maybe it's too easy. But if you skip this, you can't solve this. Kate?
X plus y.
That's correct. The first equation that we're going to get is x plus y equals 5. For some reason, because it's so obvious, people skip this equation. If you do that, then you can't solve this, okay, using two variables. It says, look at the very first sentence. The sum of the two numbers is 5. Therefore, if you add x plus 5, you get x plus y, you get 5. Now, who can tell me the second equation? It says the larger number exceeds, what does exceeds mean? Yeah, it's more than twice the smaller number by 14. How about, yeah, Tina?
I think it's like 2x plus, or
You're right.
2x plus 14 equals y?
Yeah. Isn't 2x plus 14? Look, the y is, how much bigger is y? Well, twice of the x plus 14. That's what do you mean?
Shouldn't it be like y is greater than 2x plus 14?
Oh, no. Okay, so it just means that the larger number is greater. How much greater is it? You know, y is equal to 2x plus 14. It just means that the larger number, yeah, it's greater. How much greater is it than the smaller number? Yeah, twice, and then you add 14 to that. Okay? It's a system of equations, so therefore you're going to get the third equation using one variable. Who could tell me the third equation? Anita? Oh, okay. So we're going to use the substitution method. Now, notice, I have the second equation, y is already by itself. So do you think I have to solve for one of the variables? No. So, yes, Danielle? Yeah, tell me what to write.
Put x plus 2x plus 14 equals 5.
Excellent. So in place of y, I substitute this x plus 14 in here. Do you see where you know what I'm talking about? Okay. So when you do, look at when I substitute 2x plus 14 in here, right? If I plug that in there, right, I get x plus 2x plus 14 equals to 5, right? Now, all we have to do is solve, right? Do we know how many, by the way, how many variables are we using? Only one, right? So therefore, you know how to solve this equation, don't you? Go ahead, everybody try. Oh, you already done?
Yeah.
Oh, okay.
Just do that.
Uh-huh.
Like the beginning.
Yeah.
Without using the
Right. So, you know, if you think about this, we really wrote the third equation from the very beginning from last semester, right? Using only one variable. Remember, we let x be the small number, then y is 5 minus x or something. You see what I mean? So now we're kind of separating those things and doing it in step by step in terms of using two variables. And you're right. In number one, you could have actually done it the way we did it before. But like I said, as these questions get a little bit more complicated, you want to separate these variables. It'll be easier for you to think about what the one variable represent, you know, in terms of the other. So first, of course, who thinks they have the answer? Okay, Scott, what'd you get?
-3, 8.
You got -3 and 8. So what did you get as your x? The smaller number.
X equals -3.
Good. So that's what I got here. 3x plus 14 equals to 5. Subtract 14, you get 3x equals -9, and of course 3 is -3. And how do you get y, the bigger number? You use one of the original equation. Doesn't matter which one you use. Which one would you like to use? The first one or the second one? First one is easier because we look at the first one. It says x plus y is 5. So if x is -3, what's y, guys? 8. Or you could have used the second equation if you wanted to. I mean, it's up to you. You could either use this one or the other. It's, you know. Okay, so there you are. And do you think I have to write this as a sentence? Yeah, so the numbers are -3 and 8. Or, okay, -3 and 8 are the answer.
Like the smaller numbers.
If you wanted to, yeah, you could be more specific
You
saying
already
the
know
small.
what the smaller number is.
Yeah, so I mean, if they specifically ask what are the small, which one's the smaller or bigger, but it's okay. That's good enough for this one. Any question? So, do you think it's good enough for me to verify that -3 plus 8 is 5? Is that good enough? If you're checking?
No, you have to check both equations.
Yeah, you have to check both equations. Why is it not enough to just check -3 plus 8 is 5? Tina?
Because that's the equation that you found one of the answers, so you should check both, just to make sure that it works for both equations.
Yeah. So you have to verify not only is when you add the two numbers it is 5, you have to verify also that y is equal to 2x plus 14. You got to verify in both equations. Does anybody know why that's true? Yes.
If you messed up on one of the equations, then like if you just check the one of them, you won't know that you did it the other one.
Exactly. We're solving systems, right? How many ways are there to add two numbers and make it equal to 5? Infinitely many. It could be 1, 4, 2, 3, right? -1, 6, right? So just because you got that right, you know, does not guarantee that you have the whole thing right. Because you have to make sure it is a solution to the first equation and also the second equation. That's what we're doing, right? And it does actually work, doesn't it? So when you're checking these, you got to check both of these equations, right? Just by checking one is not enough, right, guys? You know what I'm talking about? Okay. Let us then try second example. Here is the second example. Go ahead, write this down. I'll give you some time. So let's look at this. Who could tell me the equation? I mean, not equation, the variables that we're going to do. Molly? That's right. So it's very simple, right? We have two unknowns. We just declare two variables for each of those unknowns that we don't know, right? And the very first equation that you should all have gotten is, look at the very first sentence. For some reason, people always don't write that one. Then you can't solve it because you need two equations. It says they sold 23 puppies and kittens. So who could tell me if P represents number of puppies and K represents number of kitten, what's the equation? Yeah.
X plus y equals 23.
Yeah, if you use X and Y, I use P and K, but same thing, right? Yeah. P plus K equals 23. Are we okay with that? Getty, what's my then second equation? Because they said on the second sentence, they sold 9 more puppies than kittens. So what did they sell more? Puppies or kittens? They sold more puppies, right? How many more? 9. So tell me the equation.